Okay, so we've looked at extending objects so far with our elephants in the Logtalk examples, where we had Clyde as our prototypical elephant, and Fred extended him, and we could still send messages to Clyde as well as sending messages to Fred, and they would answer them. But sometimes you don't want the root of your extension to actually be able to answer these questions. Maybe if I define some abstract elephant thing, it's not a real elephant, it's not a Fred or a Clyde, it's just a abstract elephant thing, and like, it shouldn't tell me how many legs it's got because an abstract elephant thing doesn't have legs, if you understand what I mean. So we're going to look at how we might go about doing this in another example from the Logtalk directory, which is the planets example. You can find it in your Logtalk installation if you want to play along and run some queries against this. So let's jump into planets. Let's load it up first. Logtalk loader, that'll do it. And let's take a look at planets.lgt. So first of all, we'll look at protocols. So protocols can define your public and private and protected predicates for you without the behavioral part of it, the actual definition or the facts or the goals. It's just like the documentation part would go in here, along with definition or declaration that is public, private, or protected. So here we have a physical properties protocol, and anything that implements this protocol uh, should, we believe it would have a mass and a volume. It doesn't have to, and I'll show you what happens if it fails to declare this. It's a very useful tool, especially if you've got very similar objects that should all fulfill like a promise of I will provide this predicate to you, and you can change it in one place and it perpetuates through all your code. And in fact, to show how useful it is, if you just browse the Logtalk standard library, you'll see protocols everywhere, and that's for very good reason. So object M1 here is, I guess, some sort of planetary object, and it implements physical properties. It has a mass of 3 and a volume of 2.7. So let's send a message to M1 asking for its mass and its volume, maybe volume V, and has a volume. Wait, no surprises there. Uh, so what happens if we fail to keep one of those promises? Let's write that out and do a logtalk make to compile again. M1 mass now will just be false. It'll fail, just as if you had declared it public right there and not actually defined it. It doesn't have a mass. Whereas if we ask M1 for something that doesn't actually exist, hasn't been declared, that's when you get a predicate declaration massive does not exist error, existence error. Okay, so that's your protocols. There's no behavior there. There's no rules up in the protocol thing. It's just I will give you these, in this case, public predicates. Categories are different. So a category has like a protocol, or it can implement a protocol. So to define the predicates that it's going to provide that are public or private and the rest of it. But you can also you can also provide some predicates in there, some goals that can be called, and the objects that import those categories, like the Earth, you can call these predicates and they will calculate as you would expect them to. There's a little bit of syntax here, which I'll talk through in a minute, but first of all, let's just check this works. So we have the Earth down it has a gravitational acceleration, which is right there. That's not really a clever thing to try and calculate, but weight certainly would be. So some object has a mass. Oh, well, M1 has a mass, doesn't it? So what would the weight of M1 be on Earth? False, because I haven't given M1 a mass. I took it away. All right, there it is. Let's do a log talk make then. Now M1 has a mass again. That's kind of handy, isn't it? So the weight of M1 on Earth is 29 point. Who cares? So this is calling this here. Now look at this. This is so beautiful and clever, right? Because M1 could be off somewhere else in another file, and we pass it in as an object, and we message M1 here, and we ask it for its mass. And then we say, well, I need my own gravitational acceleration. This is like a call to itself, and that's defined down here. So this is because this has been called on Earth, don't forget, right? So Earth is going, what's my weight? Well, I need my gravitational acceleration, and it'll get it here. And then it just does the calculation in standard Prolog way with is. Uh, let's just show this for the sake of it. What happens if you don't do the call there? Oh, we've already got a little warning that there's a predicate that's called but not defined, and it will fail because it can't get its own gravitational acceleration there. Um, that would have to be somewhere here. Let's do a zero point 0.1 to show it's a different result here. Just as a little kind of thing to watch out for. So you see it's much smaller now because it's not the correct gravitational acceleration. It was the one I included in the category. So that's how you would communicate with the object that's importing it. You need the self thing, and within the category you don't need the self thing. Alrighty. Did I save that correctly? Brilliant. And does it still work? Yes, we're back again. So that's the difference between a category and a protocol. Other important things to note. The protocol that we implemented is called physical properties. So physical properties, if I ask it for a mass, of course, there's no mass defined, but it says object physical properties does not exist because it's not an object. I think there's a current protocol predicate, which will give you the protocols that are currently defined. You see it's a protocol, and there's also one for categories. Let's just do that quickly. Category P for planet. Yep. So planet was our category, which is down here. Now, what if I asked planet for the weight of M1? Well, object planet doesn't exist because planet isn't an object either. So the really important takeaway here is when we were playing around with our elephants in the elephant example, Clyde was our base object that Fred was extended from. We could send messages to Clyde and it would tell us, give us answers. But if we did that with planet, we made that into an object, well, it wouldn't make no sense because it doesn't have there's no generic gravitational acceleration for a planet. So we make it a category instead, and now I can't send messages to it and get answers out of it in the same way. There's a few I should be able to send, but these are for you know for development purposes, like current predicate should tell me. Nope. Yeah, so it's only the objects that can do that then. So the Earth should have a current predicate because that imports them. Yes, excellent. Alrighty then. Well, that's protocols and categories. If you have enjoyed this video and you would like to know more about Logtalk, then please hit the like, subscribe, and the notification bell, and you will be informed of new Logtalk videos as they come out, so we can keep on learning this exciting language together. Till next time, happy Logtalking.